I'd like to welcome those of you that are visiting with us. And if you've never joined us for our Tech Tuesday Demo and Discuss meetup, welcome. We do this web meetup once a month throughout the academic year. This is our last one of the year. We'll just go around and do some introductions. And if you would like to, if you're on the call and not from AET Labs, some of us are from the business here, and you want to just say your name and what institution or organization you're from, by all means, go ahead. We'll start with our team. So my name is Adam Zelny. I'm the application specialist with AET Labs. I work with directly with the sales team and all of our customers, making sure that everywhere from our labs get up and running to teaching instructors on how to use the systems and professional development and project-related content. Matt?
I'm Matt Campbell. I am a technology consultant. Cover primarily higher education in Eastern New England. So my territory is Rhode Island, Worcester East, New Hampshire, and Maine.
Kristen?
I'm Kristen. I work in marketing here, and I work with Adam and the team on promoting some of these events. And just want to let you guys know that I'll be sending out a recording of this tomorrow, so you get that in your email. In that, you'll also get a link to our summer workshop series in August, which will be about laser cutting in person, which Adam will be running. So if that's of interest, look out for that, and you could sign up for that.
Dave, if you are available and you want to chime in. If not, that's okay. So Dave Kempsky's on the call. He might jump in later. Oh, there he is. Go ahead.
Hi, sorry, I'm just multitasking here, but I'm watching. Hi, everyone. Thanks for joining.
Dave is AET's founder. Good to have you with us. And anybody else want to jump in? You are welcome to. If you'd like to say hello. Okay, David Israel, no problem. Thanks for being here. Also, so the reason we call this demo and discuss is that it's exactly that. So I'll give you a demonstration of kind of like a snippet of the technology or the workflow, and I'll always invite you to ask questions during the presentation. Absolutely welcome to do that after the presentation. Also, if you have technology that you're working on related to our topic, come in and share. And the first thing I'll start with is AET Labs. For those of you, if you're new to AET Labs, our business covers everything you see in this starter slide and more. So you'll see water jet cutter, you'll see a CNC router, CNC mill, robotics, laser cut projects, laser cutters, 3D scanners, 3D printers, and more. Today, our topic is 3D scan to print in color. So our focus is on artifact preservation. And we're talking about a little bit about how organizations are using 3D scanning and 3D printing to replicate and preserve artifacts. And when we say artifacts, we're talking anything from ancient to modern artifacts. And we are kind of going to take a look at that workflow. But before we do that, I'm going to share a couple of slides with you. And these are institutions we have worked with. So MIT Center for Bits and Atoms got, I believe, and Matt, you can correct me if I'm wrong here, but I believe that they had their own scanner already, or did they get a scanner from us?
I believe they had one.
They had one, okay. So they used their scanning technology with a Stratasys J55 multicolor 3D printer to produce the objects you're looking at right now. they're really beautiful examples. I think some of these that we're seeing on the left here were found already produced online, so they were models found online. But on the right here is an actual shoe of, I think, the lab manager of the Center for Bits and Atoms, and he produced a scaled replica of his like retro New Balance on the Stratasys J55 printer. And I love kind of the juxtaposition between these two, because when I was going through images as I was making up these slides, I thought about like what artifact preservation is about, and like how is it pertinent, and why are we doing it, right? And a big part of it is about preserving culture. So while we look on the left here and we look at, you know, like a woven basket or a like kind of an Oriental style vase, sure, those are very much artifacts from the past, but what are modern artifacts? And a pair of Velcro New Balances, I would say those are definitely apt for a modern artifact. So yeah, they're doing some cool stuff over there. I will have a link to their website later on as well. Another project that we've been involved with is Worcester Art Museum. So they worked with WPI, Worcester Polytechnic Institute, to produce scans, 3D scans using this Creaform scanner that they got from us. And they, what their goal was to replicate replacement toes and digits on the feet of this sculpture, and I believe there's a couple of fingers as well. And they scanned the opposing toe or digit and mirrored it in order to create a replica that would be affixed to the model. And what you're looking at on the right here are models printed in white on our demo J55 printer. So sculptural restoration is a really neat application being used with 3D scanning and printing. You'll also note that, you know, if you're new to what would be called PolyJet or Stratasys PolyJet printing, is that we're talking about a 3D printing technology that is very, very high resolution, very fine resolution. So your desktop, you know, 3D printer, your MakerBots, your Prusas would not be appropriate for something of this scale, right? You would be going with a resin-based, like a photopolymer printer. And if you ever want to know more about those, by all means, you can reach out to us and we could set up a call. Okay, so just a couple of samples projects. So beautiful examples from the Stratasys J55 here. And we have more if you're ever interested in seeing more. Happy to work with you. And now we're going to move on to just kind of our demo project, my demo project, actually. So, you know, AET works with educational institutions across New England, and you know, kind of my time and resources are limited to practice stuff like this. So I asked myself, okay, if I'm actually going to go through this process to show our community, what should I tackle? What should I find that would be a great example here? And my mind went immediately going to like a secondhand store, because if you've been into any like Goodwill or Savers or Salvation Army, there's always that section of the store that has just stuff, right? Not clothes, but just you know, knickknacks, dishes, what have you. And I came upon this Spanish oil jar that was perfect for this project. And what we're looking at in this image is the original on the left and two scaled versions down to a scale of 0.75. And this middle print on the J55 was done with a specific color profile. So if you look on the right here in my my scan and print info, we have color profile Vivid CMYK, absolute color metric. And you can immediately see that colors are very dark. Contrast is okay, but we ran two prints to explore different different color profiles, and the one on the right is a little bit brighter. And when we're working with color 3D printing or color 2D printing, and if you have any experience with this, you may already know that it's never tried and true. What you see on your screen is not what you're going to get on your print, because we're working with a physical media, right, versus like a digital media. So there's always going to be some trial and error until you find the correct settings to reach that color template. The model on the right is finished with some light sanding and buffing, and one coat of clear enamel, like Rust-Oleum spray enamel. If I put on another coat of that enamel, the sheen would be probably identical or nearly identical to our original model over here. Which, of course, I guess I should have talked about the contents of the original model too here, but we're looking at you know, a ceramic sculpture that has been kiln fired and glazed. It might be hard to see, but if we scrutinize that model, there are even cracks, like little cracks in the glaze that can be seen. All right, so some of the information here for our scan and our print, we use the Creaform Academia 50, which is a white light scanner. White light scanners are necessary in order to capture color texture. And the Creaform scanner comes with the VX Element software suite, which is what I will show you in a little bit. It's what's used to basically kind of repair the scan, merge scans together, and get it ready for your final product, whatever that may be. Mesh resolution is 1 millimeter. That means that every polygon or triangle that makes up the mesh has like an area of 1 millimeter. And the texture resolution is 110 dpi. The scanner can only go up to 150 dpi, the one that I used for this. And Creaform does make, you know, several tiers of scanners that have different resolution capabilities. So 110 dpi, if you are familiar with photography, digital photography or printing, is very, very low. So if we look at these, you know, kind of the detail in these, our original versus the scan, you can tell that we're missing some detail here. The general concept is very clear and the artwork is preserved, but we'll never reach this level of detail without using a higher end scanner or the method of what's called photogrammetry, which is making 3D images with photographs. So, but still, for this entry level education scanner, I was really, really impressed with this product. Print info, Stratasys J55 Prime is our printer. This PolyJet, Stratasys PolyJet technology. Scale I already mentioned. Layer resolution 18 microns or 0.018 millimeters. When I switch back to, you know, switch off my presentation, I'll actually hold the models up to my camera so we can take an even closer look at them. And color profile, I already talked about different color profiles that we can work with in our software. All right, before I just do a little bit of show and tell in the software, I just want to bring these terms to your attention. When I work with some of our community in 3D scanning, especially when it comes to texture mapped images or textured 3D models, some of these terms are new. So I just want you to bear them in mind as we look at our models here. But the model that we just saw, this 3D print here, was made possible with a combination of these three file types. So an STL, which is a shell of a 3D object made up of connecting triangles, a BPM or bitmap, a 2D rendering of an image made up of pixels, right? We're talking about like how an image is on your television or photograph on a computer screen. And then MTL, which is really interesting, kind of the hidden file type that we don't know much about, material template library. And in this case, it describes how the bitmap file should be applied to 3D geometry. It gives coordinate data to so the STL and the bitmap can talk to each other, and essentially the bitmap can wrap its 2D image around 3D geometry. All right. So in some of these meetups, I will do kind of a deep dive into a workflow, but we're just doing kind of a helicopter view of our software workflow here. And what we're looking at here is VX Elements. This is the software suite included with the Creaform scanners. It's a really nice interface. I love working with it. And what we're working with here is we're kind of doing post-process work here. We're working with just an STL mesh that has a texture map on it. And to kind of hit home here. Let's see. Yeah. All right, so this is our STL. This is our geometry. And for those of you that are familiar with this world, this is a lot what we see often for 3D printing. There's no texture; it's just a solid color. And we can see that it consists of triangles, polygons. Our texture, or our BPM, looks like this. And just to make sure, Kristen, can you see this image okay?
Mm-hmm. Yep.
Excellent. Yeah, so this is our 2D rendering, our bitmap, that gets kind of wrapped around our geometry. And what's really neat about this process is if I go into my final rendering here, that includes my bitmap, my MTL, and my, in this case, 3D object STL, I can actually go into the bitmap and open it. And I can edit right here, this model. If I went into like edit and create. No. So if I went into, opened this up in like a pixel editor, I could change anything in here and it would then be applied to our 3D model when we open it up again. And that is actually how I went in and did a little bit of editing for this. So one thing I'll show you back in our VX Elements is when I was working with this model, there was actually a bug that occurred that has since been resolved with Creaform tech support. And when I did a little bit of post-processing work, these weird little kind of anomalies showed up, right? And you can see them here on the inside. And it looks like some of the triangles did not, they didn't get mapped properly, or maybe the MTL file got corrupted to some extent. So I had to go in, and this is of course not typical of the workflow, but I like that it happened because I can talk to you about what you would do when you are kind of repairing the texture of a model like this. And we would go into our bitmap file and simply do something like edit with Paint 3D. And I would go in and find an anomaly. This one has already been all fixed, but let's say, there was some issue over here and I needed to do a little bit of spraying to heal it. And you can see up here, this will change color too. If I save this, this will immediately be applied to our 3D object. So it's a very quick and easy way to kind of repair any color issues. You can even brighten up your object this way. I mean, you know, this gets down into like kind of like Photoshop style editing, but it's a vital part of working with texture mapped 3D objects. So pop out of this. All right, so that's kind of the just what we're looking at on this side after, you know, the process that occurs in VX Elements is, you know, of course, you're producing your scans, you're merging scans together, you're doing a little bit of fine polishing. One thing I will point out is that our actual model, and I'm actually just going to pop over to GrabCAD Print. This is our essentially our slicing software for the J55 and all Stratasys printers. But this is kind of more true to our real model because it shows like a glossy sheen. And when you're using a 3D scanner that is projector based and shooting light out of the scanner at an object, if an object has a luster or a gloss finish to it, it actually can be very difficult to scan. And this one, let me share my camera here. So, so I believe I should be kind of, Kristen, can we pin me so I'm full screen?
Yeah, let me try to do that. I think it pinned for me. I don't know if it's pinning for everyone.
All right.
Oh, spotlight for everyone.
Okay.
Yep.
Great, thank you. So yeah, so this is our original model here, and you can see it is quite shiny. And with this Academia scanner, it really did a great job of capturing details and geometry. The scanner will do, again, we captured it at 1 millimeter resolution, and the only part it struggled on was the kind of the lip up here where the geometry sharply curves. But if we take a look at our finished model, it actually didn't do too bad, but you'll see it's a little rough comparatively. So these are things that we would expect, okay? And they're variables in any process of scanning to printing, whether you're scanning with like an entry level or even an advanced scanner, geometry plays a huge role. Here's a closer look of our the difference between our unfinished model here. This model, when it came out, it was covered in a support material that the J55 prints with. So it's actually the J55. It is possible to print something that almost has a similar gloss as this, wherever there is no support material. I know it's kind of tough to see the inside here. Oh, you know what I can do? Let's see. There you go. So we were able to capture a bit of the inside edge as well. And it came out very well. And you might be wondering, how are we, what do we do about the inside? Like, how is the inside geometry rendered, right? We actually can't scan the inside. So let's pop back over to VX Elements here. And I'm not going to go through the process, but I'll just quickly explain to you what I did. And for those of you who are CAD designers or engineers, you'll be familiar with this. VX Elements has the ability to shell or offset. So essentially what I did was I made a cut at the top here. I actually might even have it. Let's see. Yeah, there we go. Yeah, so So I made a cut at the top of our container of our scan, and I offset it by the approximate thickness of the bottle itself. And then I merged, where is it? Yeah. So then I merged a previous scan to blend, and you can even see the blend happening right here, to blend the inside, or the upper opening of the jar with our shelled geometry. In another part, just because it's kind of a neat thing to look at, is we can take a side view here, and we can do a quick clip view and give ourselves approximately a halfway view to see, how close are we with that merge. And you can see it's pretty close here. This is kind of the offset between, this would be the shelled version, the line of I guess the cross section of the shell here versus the original, which tapers off just a little bit. Calipers inside and measured, this kind of midsection of the neck of the jar. Yeah, really cool process, and not too tough to get to that point either in this software. Really, it's really kind of a pleasure working with it with respect to that. Okay. Let's see. All right, popping over to GrabCAD print. So after we finish our scan in VX Elements, and we've edited our bitmap file to clean up any texture issues, we now bring this this OBJ, and just to show you, if you're not familiar with this workflow, as long as you have these file types in the MTL file and bitmap file in the same location as your 3D object, it's really in, they're kind of wedded together. So if I grab this 3D object and copy it, oh, saying not loaded, hold on. Oh, all right. Well, this is not working for me, unfortunately. All right. Well, the file that you just saw originally was a drag and drop of our objects here into our GrabCAD. And I guess I can just open up the projects file here. Oh, wow. All right, unexpected technical error, everybody. All right, so bear with me. So what we'll do here is we'll just kind of skip this part. Prep, what I would go over here is just like kind of prepping the print. There's not really much to do aside from your orientation, but this is pretty much your, I could probably bring in a different file here. Let's see. Bring in another file. Oh, wow. Yeah, I'm getting kind of, I think this must be, maybe this is a GrabCAD issue. Let's just restart it. While I'm reloading this, does anybody have any questions or anything they would like to kind of go back to? All right, let's try this again. There we go. There's a nice textured granite rock. It's very exciting. Let's see. And let's go grab the Spanish oil jar. Okay, there we go. That's how it should behave. So yeah, drag and drop. There's our textured object here. And GrabCAD has a nice feature of where if we have any model errors detected, we can kind of analyze it. And down here, it's here, it's showing self-intersections, open faces, inverted normals. Sometimes it can be very hard to find where an error is. Looks like we have something right there. So an open face right there. It's a nice feature of the software. And this goes not just for PolyJet, but for regular kind of like FDM or fused deposition printing. You would see these errors as well. So I can repair that, and it does a pretty good job of kind of smoothing everything out. And yeah, now we're kind of concerned with finish. Dave Kempsky he's kind of situated at the office most days, and he helped me get this printed because I'm a good hour and a half from the office. And when I was going over the workflow with him, he was like, "Oh, you should print it." I was thinking just print it flat like this, right? Because it'll take the least amount of time. But they pointed out that, well, it'll also fill up our entire cavity with support material. Whereas if I do an orientation upright, we'll actually have a nice kind of like open cylinder where there will be no support material. And I'm glad he pointed that out, because when I went through the process of cleaning this, getting at the support material inside was very difficult. Typically, you're using like a high pressure water jet to clean out the inside or any support materials, but I did not have access to that. So I was just kind of using like various plastic tools. So this was our orientation. And the next thing we would go to is our tray settings. And that's where we take a look at what materials we have loaded. We have CMYK, white and clear. And down in our advanced settings here is where we can choose a color profile. And this is perhaps one of the biggest, especially working with a textured model, is one of the biggest troubleshooting factors. If I switch to X-Rite CMYK saturation, you'll see that it just got a lot darker. Let's see if we can switch back again just so you can see that better. I'll go back to absolute. All right, and that got at least like 3 shades lighter. So all of these color profilers will give you different results. different subtleties. And some of them will even only use specific materials. In this case, this would just be using CMY. So cyan, magenta, and yellow. So it's an interesting game to find a color balance here. In most cases, you'll probably be wanting to make physical swatches of where you are printing an actual color from your model, just as like a little sample square or circle, just so you know what it's going to actually look like when it gets printed. You'll get an okay representation here in GrabCAD, but it will never be true to life. Of course, it's just the variable of lighting and kind of the real world exposure is going to be it's going to be different every time. Yeah, but aside from choosing your color profile, we also have the ability to choose a matte or glossy finish, which is also kind of rendered in GrabCAD, which is nice to see. And one other thing that I did here was we chose sure why it's letting me now, but we chose this this coding option called polishing layer, and what that does is it adds a I have two objects here. It adds a layer of clear resin, a clear material on the outside, and you can even define the thickness of that layer as well, because you're going to be taking down or sanding down some of that layer. I thought that was a neat feature, so we gave that a try this time. Okay. So the last thing I wanted to share with you here was some resources. So you should have a slide up right now that lists some articles and resources for your own kind of perusal. The first two articles are just news. They're just news articles pointing to places or institutions who have used 3D scanning to do artifact preservation. The first one's pretty neat. They use a Creaform scanner to scan an ancient canoe they found in Lake Mendota in Wisconsin. And then the other article is this how the Smithsonian is using 3D scanning. And that's a nice one to look at because they have a video, and they also one of their projects is scanning a giant like decaying boat. So yeah, it's a really pretty cool application.
I just shared them in the chat in case people are having a hard time clicking through.
Thank you. Resources below that, you have a couple of pages. One is Scan the World and GrabCAD Community Library. Both of those allow you access to downloadable files. I believe in Scan the World, I was able to download a file, like a textured file, without logging in, but in GrabCAD Community, you do have to have a GrabCAD account. But they're free files to download. If you're 3D printing on any type of printer, if you're 3D printing on your standard kind of desktop MakerBot, or you're using a PolyJet machine, you can find tons of cool models to print. Below that are just links to our website, to our Academia series of scanners from Creaform and the J55 specifically. And if you're exploring that tech, like the J55 or PolyJet technology, and you're looking for something that would be closer to entry level on the multicolor side, the J35 is also a very interesting option, and it's a little bit smaller, but you're limited to, I think, 3 or 4 materials, so you won't have full multicolor, but you get to start kind of experimenting with multicolor in that way, and multi-material.
Adam, quick note on the J35.
Yeah.
No color, black, white, clear. So you get grayscale.
That's what I guess that's what I mean by color, is that you have, is you have those options. Yeah, right. Yeah. But yes, it is exclusively grayscale. Thank you, Matt. But if you look at some of those, some of the J35 samples, they actually look great, right? They're like right out of it's like NASA stuff, you know, space engineering, silvers and whites and blacks. So it's pretty cool. All right. Well, we got a few minutes left here. I'd love to hear from you folks, or if you want to just say hello and chat, introduce yourself, say what you've been up to. It doesn't even have to be 3D scanning. You just be like, I've been working on this amazing CNC project, or I went for a walk in the woods the other day. Kevin, you want to jump in? How are you doing? You're muted right now. There you go.
How's that? Got it?
Yeah, we got you.
Yeah, doing fine, Adam. Thank you. The scanner and the J55 are a great combination in terms of we've gotten some really nice models. We have some folks visiting from France here taking a course on C programming, and this is actually the bad model we got. I don't know, can you see this?
Yeah.
So what they were, they use Linux over there. So we got the little Linux Penguin and C for learning C programming in that, and made these things up for an award. So folks that did really a nice job. But we also made them in tiny little objects too. So we could make tie tacks and earrings out of these things for the kids that participated in it. So it was kind of fun and nice. I have to tell you, as I say, it came from Polytechnic, L'École Polytechnique in Paris, and it's exclusive. It was actually the model for Dartmouth Engineering School many years ago when General Thayer funded it. So and Napoleon had started their school. So all these Parisian kids over here participating in our program was sort of fun. And they found that J55 just jaw-dropping in terms of its functionality. Yeah, so.
That's great, Kevin. Thank you. Yeah, that's, Kevin has a display shelf outside of his lab that has some breathtaking models in it. Yeah, you've been putting that machine to work. It's good to hear.
Now, in the past, we've had a lot of fun scanning the students themselves. Haven't tried that yet with the Creaform scanner and so forth, but that's really popular when we have visitors with children, especially. You know, we all remember when our kids had these plaster models of their hands up on grandma's wall, but the 21st century version of that, of course, is a scan with a little kid on that, and it's a lot of fun with that. So I haven't tried it yet with the Creaform, but I'm looking forward to it again, putting something like that together.
We have a customer at I think it's Belmont Hill School, Matt, and they had just gotten a Creaform from us very recently, and the teacher was asking about scanning hair, right? So if you have with the academia at least, and you're trying to scan someone's head, if there's a real high sheen to the hair, it's not going to render the geometry. So if you haven't heard me talk about it before, or Matt, using Dr. Scholl's spray powder it will allow you to scan otherwise unscannable geometry. So I told the teacher that if the student was willing to have the Dr. Scholl's powder sprayed in their hair, that it should work.
Or they could put on a hat.
Or they could put on a hat. Yeah.
Or shave your head, you know.
Or shave your head.
Which I
Very
recommend. So, yeah.
Cool. Thanks so much for sharing, Kevin. And Adam, welcome. You and I have just been chatting over email, I know. It's good to see you almost in person.
Yes. We're still trying to get the lab and everything up and running. We're still doing a pass off on some of the stuff for our scanners, but hopefully I'll be in contact with you in the next week. But setting up our space so far has been very exciting, getting closer every day.
And Adam, can you just tell us where you're at?
I'm at MassArt, and we're starting our first digital fabrication space that's going to be open to the whole school.
Yep, very cool. Very cool. Yeah, you guys have a lot of stuff.
So we're really interested, Adam, in getting scanning to CAD going forward. We've had folks that restore old cars, and benefactor had come by with this is a stanchion for the windshield on a 1928 Plymouth, and he would like to get that into CAD so that we can make a pattern for casting these things going forward. It looks like a pretty daunting process, I have to say, to tell you the truth. But that's really a huge payoff for us, if we can get the skills down so that that can be done efficiently.
Yeah, you're doing, I mean, that is reverse engineering, Kevin. So it is one of the tallest orders when you're doing kind of scan to CAD. It's yeah, it is tough. But when you showed me that project, I was still learning the Creaform platform. So hopefully we can kind of reconvene on that, and maybe I can do another Tech Tuesday where we focus just on that, because I don't think we've done one for that.
Yeah, and of course, for the benefit of other folks that may wonder what the big deal is with this. Of course, the problem is that we get a point cloud of data out of a scan, but CAD software is feature-based. That is, it needs to identify planes and holes and the geometric elements here in order to have the array on a feature tree that describes the components going forward. And it's as I say, it's somewhat daunting. You don't really realize how complicated engineered designs are until you start to go in reverse in that way.
Yeah.
So I don't have any direct links right now, Kevin, but if you look up, I'll put it into the chat here. If you look up this term, NURBS surfacing, your VX Elements software is capable of doing that, and that is one of the kind of big features of the system. So when you surface a mesh in VX Elements, it turns it into a solid body that can be manipulated in your CAD software. So the next time you or one of your students pops open VX Elements or VX Model, try using just start with auto surface. There's a function called auto surface, and that will render, a solid part that you can bring into your CAD software.
All right, give it a try.
Well, unless anyone else would like to jump in and say hello or have any questions, I think we'll probably wrap it up for today. And as always, thank you guys for coming. And definitely, particularly for our last Tech Tuesday of the season. It was a good one, so glad you were here. Kevin, hope to see you in person again sometime down the road when I'm cruising by your neighborhood. And Adam, looking forward to visiting your lab again. I was probably there before you were there. And but Matt and I are really looking forward to get back over there. It's a really nice space, and yeah, we're excited to work with you guys on that project.
Thanks, y'all. Hope to see you soon.
Thank you, Adam.
All right, Kristen, thank
Bye-bye.
you. All right, see you guys.